Earthlings. This is Piro 314, broadcasting worldwide, I believe, from the great state of Maine via the MCWCMM. Let me start that again. Via the MCWCAM broadcasting platform high in the midnight stratosphere. Welcome. All right, we have two things. Versus each other. See, as an exercise to the viewer what the value of the relationship is. Okay, first, you have this thing Texas did with the abortion. It's ridiculous. It's absurd. The Supreme Court should have weighed in. It's not like you're allowed to trick the law and everybody knows you're tricking the law, but let's talk about a different thing. To me, it's just interesting because if this does stand, it means states can do anything. Okay, because here's how it works. If people have been paid attention to it in brief. So Texas didn't make abortion directly illegal. They made it. Everybody's probably heard of this, but knows the details. I mean, but they made it so you could sue people that abet an abortion. Right, and the whole trick is that way the state is not putting someone in jail who then has a standing to sue. Now, I think people that are sued could still say it's unconstitutional as a defense, and I don't really understand why you can't sue the judges or the court system directly, but I guess you can if you go to court. There was a guy on a Majority Report talking about it because there's different restrictions suing judges and things like that. But anyway, it makes it harder to get standing. But really only if the court's willing to go along with that fiction. But of course, they've packed the court with people that care about nothing as much as Roe v. Wade going down in flames and prohibiting abortions. Okay, but I wanted to talk about that trick. So that trick could be used for anything. Like you could say, a liberal state could say, hey, they can't say make it directly illegal to wear a MAGA hat, but they could say, well, we allow you to sue for $10,000 anybody that abets getting a MAGA hat, right? Oh, we're not going to make guns illegal. You got the Second Amendment, but we're going to make it legal to sue anybody that abets you getting a gun. So $10,000 from the gun store that we can't close down directly, but we can make it legal to sue them in the state court. So you could do anything because that's the situation here. The last ruling on this, Roe v. Wade, says that you can't prohibit abortion before the fetus is viable outside the womb, which, is reasonable. Now, technology might change that date quite a bit. If you had an artificial womb, maybe the baby could be in there the whole time, from when it's a fetus, from when it's a little zygote, when it's a little egg. Who knows? But for right now, if something's growing off your body and you don't want it, then it's essentially up to you to decide if you want it removed. Just like if somebody breaks into your house in a blizzard, it's actually up to you if you want to remove them from your house. And so regardless of if you agree with that or not, or if people do, that's what the Constitution says. So getting this end run around it is a way to get absolute power back to the states, which is interesting, because then the states can, they can charge a tax for interstate commerce by abetting those that don't charge it, and whatever weird kind of shit. So I don't see how this is going to turn out well for anybody. Certainly it's not going to turn out well for Texas, I don't think. But just the idea that they're going to get away with this, if they let them get away with this, there's nothing the state's going to do. And the idea maybe is that you have a Supreme Court that'll only back up this reasoning in the case of abortion. I don't think so. They'll have to go, there's some wiggle room for that, but basically it's going to be more an absolute states' rights thing, which is going to allow the states to really get at each other's throats. So, because violating anything in the Constitution by letting people sue, inventing tort solutions, is just going to be expensive and ridiculous and destructive. So that's stupid. All right, now versus the physics part of this. So I thought it would be interesting to talk about what units mean. So because this is the main thing you need. Let's get a blank piece. Which is like, let's say you have the joule. Okay, I'm going to try to remember this correctly, but I believe this is kilogram meters per second squared. Is that right? You know, I should just check that in case I'm... No, that's force. So it's meters squared. Yeah, that's right. So let me just check that. Joules, units. Yeah. Okay, so how do you get something like that with meters squared and seconds squared and stuff like that? Well, it's really pretty straightforward. I mean, one thing you have to remember is that, let's say you had a fraction 1/2 and you divide it by 1/3, and you're asking how many times can 1/3 go into 1/2. Well, if you remember, this is the same as 1/2 times the inverse of that guy. So 3 yeah. So 3 over 1. So that is going to equal 3/2. So 1/3 goes in 3.5 times, or excuse me, 1.5 times into 1/2. Right? So you have to remember that trick. It's not really a mathematical trick. That's how that works. That's how you divide fractions. Now, so now if you have something simple like velocity equals the change in distance over the change in time, right? So that's meters per second, right? Because time has the unit of seconds and distance has the units of meters. Should I go check my comments? Nah, I don't have time for that today. So now acceleration is the change in velocity over the change in time. Okay, so the change in velocity, that's going to have the units meters per second, and time is going to be over seconds. Okay, and remember, seconds equals seconds over 1, just like 5 equals 5 over 1. You need to know that because you're dividing a fraction, and so you do the same thing where you're going to have, this is s over 1 on the bottom, so you have seconds, times 1 over s. You multiply the top and the bottom, and you get meters over seconds squared. Right. Now, when you have things multiplied by each other, like kilogram meter, what does that mean? Well, multiplying comes from this concept of squares, and if this is x and this is y, then the area is x times y, because you take this and you multiply it by that, and you basically are getting all the slices, right? So that's how multiplication works in general, in physics as well. So if I have a kilogram, oh wait, is my thing? Yeah. If I have a kilogram and I'm multiplying it by a meter, what I'm saying is I took a kilogram and I moved it 1 meter. So well, it could be part of another equation, right? Now, why do you have seconds squared on the bottom there? Well, because I took the seconds and they kept changing how long something took. So, for example, since when something's falling, something's being pushed by a force, it's going to go a certain velocity. So let's say it's, like the 9.8 meters per second squared. That means after 1 second, the thing will be going 9.8 meters per second squared. Or excuse me, meters per second. Right? Because it got, per second, it gets that velocity. And the next second, it's going to get that again. So 19.6 meters per second at this point. However, this is 1 second long, but it's actually a greater distance because this thing is going faster and faster and faster. Since the speed is changing, if we were to look at a chart, you'd see the velocity is going up linearly with seconds. But the distance isn't going up linearly because it's going faster and faster and faster. So as time goes, it goes up like a parabola, the distance. And this is the squared graph. So that's why. So I'm going to go on and decompose these. I've already done this in previous videos, but I'm going to start doing it in streams. And we can see how we get a number like this, and why we also have things like, the fact that, F, I want that thicker, I think. That F can equal mass times acceleration, but that's also the same as the change in P. Is it just the change in P? No, of course it's change in P over the change in time. These things can all equal. Delta P is, a delta m times delta V. And again, why would you have mass times the velocity? Because you're taking that mass and you're moving it through the velocity. When the velocity is changing, or even if it's constant, they get multiplied together. That creates a unit representing those things joined together. And basically, to finish up for the day, I know I'm rushing through this, but it is a quick battle. The point is, you basically, in physics, you have 3 things. The things are mass, which you might think of as weight, just different. You've got time, and you've got distance. Okay, and since this is 3D, that's also called space. Okay, and so you have, we'll use kilograms, but obviously it could be pounds. We'll use seconds, but obviously it could be years. We'll use meters, but obviously it could be feet. Right? Now, given that, you simply have your D, your T, and your M for mass, right? And your velocity is change in D over the change in T. Acceleration is the change in V over the change in T, right? And then F, we introduce M times A, right? And then in work, we take that force and we apply it for a distance. Force times distance means that I applied the force and I went a distance. So similarly to that, momentum is F times time, meaning I applied a force for 5 seconds. If I apply a force for 5 seconds, I will impart a particular amount of momentum. Oops, sorry, MV. I meant to draw this originally as P. This is P equals F times time. And so you could see that because what does F equal again? It equals mass times velocity over time. I'm going to leave the deltas out. When you have to be careful and plug numbers in, that's when you really have to be that. Times T. Okay, so this part, that's F. And this is the times T part. And as you can see, you've got an under T there and you got an over T. And so that equals MV. So force times time equals MV. Work equals force times distance. So that means if I apply a force for a particular time, I impart a particular amount of momentum, regardless. If I apply a force over a distance, then I apply energy, or work rather, which is energy. So this is how everything pieces together. And really, once you get to energy, that's the most complicated sort of a unit decomposition that is required to start to understand everything about thermodynamics and all the accomplishments of 1,000 years of physics, arguably. So that is my contribution to the world. I wanted to get that before I went to bed. And so, I sort of did. I mean, I did, except for I think I started at 12:01, so it's tomorrow. But it can't be tomorrow when I'm saying that right now, so maybe not. I'm going to go, but real quick, I'm going to check to see if there's YouTube comments, which I doubt it. People will probably say hello. Nope. What the hell? Ridiculous. Did I actually go streaming? What the hell? Is it because I don't have a Patreon and therefore I lack legitimacy or something? You guys have to get this together. Okay, tell me which one won. Is it the Texas trick or the primer in mathematical physics, Newtonian physics? So it's up to you, you guys. All right. And by guys, I mean guys and gals. I mean gender neutral, everyone. But you knew that.